Hello, y'all. This is Tim Nutt here. This is the homework assignment for lesson number 6 in the incredible Pico W tutorial series by Paul McWhorter. The link to this lesson will be from Paul McWhorter's video. The link will be down in the description back to his video. And this will be the homework assignment for it. It's a beginner-based tutorial series, basically using only the principles that have been taught thus far in the course. Hopefully it'll help, or at least provide some entertainment of me stumbling around. But anyway, the homework for this video is, excuse me, to set up a potentiometer and 3 LEDs. Potentiometer, when it's twisted all the way to the left, you're reading 0. When it's all the way to the right, you're reading 100. And then each of the LEDs, the green, yellow, and the red, at up to 79, the green LED will be lit. Over 79 but below 94, the yellow LED will be lit. And then above 94, the red LED will be lit. And the others will obviously be off. So let's get started on the build here. I'm going to go kind of fast because we did the potentiometer build last video, and Paul showed how to do it as well. So first we need to get ground, and we're going to use physical pin 38 tied to our ground rail, if I can get these in. My big old fat fingers here. And then to get our positive for the potentiometer, we're going to go to, it'll be, I guess might help if I bring this up as well. We're going to go to physical pin 36 to provide power there. So drop that in there. There we go. And then let's see here. We will do this. Say here. Actually, yeah. Actually, well, can't remember which slide I put that in before. But anyway, for our potentiometer out, we're going to use physical pin 31, which is GPIO pin 26 or ADC0. And that'd be, count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we'll go from pin 10. Let's see where that, okay, that lands there. There's, that'll work. So we will now to the left of the center pin. It's going to be our ground. So let's go connect that to ground there. And then we will put to the right of it will be our positive voltage. Alright, there we go. We got that in there. Now we'll set our potentiometer. This isn't the potentiometer that is in the kit, but I like this style better. This is the one that's included in the kit, and I just, like I said, I like this one better. You can use either one though. Both do exactly what you need. Alright, now we need to set up our LEDs. So, and for this I'm going to be using pin 7 for the green, 9 for the yellow, and 10 for the red. So pin 7 is physical pin 10. Actually, let me take the potentiometer out while I'm running these. It'll make it a little easier. Put it back in a minute. I'm just going to let that fall where it wants to there. And then, so we're using pin 9 for the red LED, which is physical pin 12. So we'll skip one. That should put us in 2 more there. And then said GPIO pin 10, which is physical pin 14. See if I can split these in the middle, make this kind of neat here. If you don't have a pair of tweezers like these are very handy for many of these components, especially the wires there. I'm gonna drop, let's see if we can get that one in there. There we go, and 14. That should bring us 2 more over here. Oh, that's fairly neat. Alright, now we should be able to put our potentiometer back into place. There we go. We're going to turn it all the way to the left. Right, now, let's set our current limiting resistors in. Put that one in there. And that one will go right there. Now we'll bring our LEDs in. The short leg goes to ground, the long leg goes to positive. Try to get these in the right there. And we'll have our yellow right there. And our red right there. Alright, I think that should complete the circuit. So let's get rid of this real quick, and we got a little bit of math to do here. Bring this up. So just to give a little, said I'm not as good explaining this as Paul McWhorter is, and I'm still refreshing my memory from school days as well, which is quite a while for me since it was high school. Never been to college. But slide this over a little bit. Right over here is what we're doing at, and we'll show these values that we figured these out last video, but when we're all the way to the left, we're reading 336. We're all the way to the right, we're reading 65,535. And we want to read, when we're all the way to the left, we want to read 0. When we're all the way to the right, we want to read 100. So we need to calculate the slope, and that is the y2 minus y1 divided by x2 minus x1, which is 100 divided, or minus 0 divided by 65,535 minus 336, which comes out to 100 divided by 65,119. So to get the formula we need, y equals y, or y minus y1 equals m times x minus x1. And y minus 0, there's our m, and x minus x1 is 336. So we drop to 0. There's our M times X minus 336 times 100 divided by 65,199. So the actual formula we use after we simplify it even more, our readout, what we're looking for, is equal to 100 divided by 65,199 times pot val, which is our X, minus 336 times 100 divided by 65,199. And that should give our scale. All right, let's straighten this up here. Pull that out of the way. Let's go over to our code window. We can see what we're doing. So now, a little bit of keyboard here. Now we need to import a couple libraries here. Let me click on here. So from machine import. Oh, I'm all capitals. I did not mean to do that. There we go. Let's see. Import pin from time. Import sleep. Then we need to set our pins up. So let's do our green LED is equal to pin. We said our green LED was pin 7, which is a pin.out, close parentheses. Our yellow LED is equal to pin, and we said our yellow LED we're going to use 9, and that is a pin.out. And then red LED is equal to, we said that was pin 10. Oh, equal to there. Pin 10. There we go. Now we need to have our pot pin that we're using, which I believe was GPIO pin 26. So pot pin is equal to 26. And we need to set our delay up. So we'll just do DT, which is my go-to for delay unless we have multiple ones. And we'll set it off at 0.5. Oh, almost forgot. We got to set our pot up. So our pot is equal to machine, if I can spell, machine.adc, all caps for analog digital converter. And we're reading that from pot pin. That's where we're reading that from. Alright, now let's set our while true loop. While true, don't forget your colon. And we need to get tell our pot val what we want it to do. So pot val is equal to pot, which we set up there is for the analog digital converter. So pot dot read underscore U16. I think I did that one right. I will find out in a minute. So now our read out is going to be equal to, and this is the formula we did the math for. So it's equal to 100 divided by, wrong one, divided by 65119. Close that parenthesis. Then we need to times pot val. And then minus, put a space there. Just I like spaces. I don't know why, but anyway, so minus 100 times 336 divided by, wrong one, divided by 665119. All right, and let's print readout. Print readout. Let's see if we did this right here. Let's hit run real quick. 13. Oh, we forgot our parentheses on readout. I think that was it. Let's try it again here. Let's support. What did I do wrong? That in there. The print readout. Unsupported types for float bound method. I don't like fits. Line 13. Let's read out. Okay, this is line 13. That equals 100 divided by that times pot val. Maybe I don't like the spaces. No. Not sure what I did wrong there. 65119 times pot val minus 100 times 36 divided by 6519. We got our parentheses in. Stop a minute. I'm not sure what we did wrong there. Yeah, we're not supposed to put a time now. Yeah, need the time. Readout equals. No, we just did this. Okay, yeah. Unsupported types. Okay. I don't remember that. Let me double check my. Right way. No, it couldn't be. across there. Not sure what I did wrong. Float pound method. Good. Pot valve sped right. Pot. Read. I don't think it has anything to do with it. Still unsupported types. I think it's supposed to be 9 centium, 199, not 119. No, that ain't got nothing to do with it, but change that ADC pot pin. Pot pin is 26. Pot dot read. That actually has me stumped. Let's see here. Let me check something real quick. What am I? Okay, I got... Oh, that was it there. Sorry about that. I hope I didn't come across. Go back looking code for last week here. And see what is different. This is confusing me. Wait a minute. I think let's see, we forget our, there we go. We forgot our parentheses. That's what we did. Okay. Now that makes a little more sense. Alright, so all the way to the left is 0. Now we go to the right. Should climb up to 100. There we go. Good. So this is working good. Let's just check our LEDs real quick. And then before we continue coding there, let's just make sure that they are working properly. We're just going to turn them on real quick. Let's just go green, LED, value. There, we'll hit F5 to refresh. Okay, that's on. Good. And then yellow, LED dot value 1, and hit F5 again. Alright, good, that's showing. And red LED dot value, turn that one on. F5, now we got all of them on. Alright, now so they're not annoying us here. We're going to turn them all off. And then get rid of that there. Alright, so let's take and put our delay down a little bit, get it out of our way. Now we need to do our if statements. So, and our conditions were if up until 70 equal to or less than 79, the green LED would be on. Over 79 but below 94, the yellow LED would be on. And over 94, the red LED will be on, and the others will be off. So let's do if readout is readout is less than, see, I think readout is less than 74. Oh, don't forget our parentheses, we already did that once. No, that's greater than. If readout is less than 70, not 40, 74, then, and, oh, get a colon, we want green LED value to be on. We want, now we want to make sure the others are off because we don't know what state this was in before. So each time we're going to set the values for these. So yellow LED value will be 0 for off. And red LED value will be 0 also. But now let's just check and make sure this is actually going to work. So we're before we go doing the rest of it there. We refresh. Already green LED came on at 0. Now it should be, let's watch it, make sure it turns off once it gets above 74. Actually, no, it won't. It won't turn off because we haven't done our next one yet. So let's Control C, and then we'll leave a little space. Here we're in the right spot. Control V. But this time, if readout is, actually, on this one we wanted less than or equal to. Sorry about that. So now we switch it. If readout is greater than 74, and see how it turns red color there, and readout is less than or equal to 94. Oh, parentheses again. And I am hitting all kinds of keys here. There we go. Now that's back in the right spot. If we're in between those values, we want the green to be off, but the yellow to be on. So if readout is greater than 74 and readout is less than, I like my spaces, is less than 94, the yellow LED should be on and the green and the red should be off. So now let's go and do another one here. So if readout is, actually no, why not 74, 79? I don't know what I'm thinking here. I am tired. I've been up way too long. It's like 3:30 in the morning. I gotta get up and drive tomorrow. Anyway, I want to at least get these out because I've been falling behind the last couple of weeks. So now we need, if it is greater than 94, then we want the red LED on, the yellow and the green one off. Bring that up a little bit here. Okay, so if the readout is less than or equal to 79, green LED's on. If readout is greater than 79 and readout is less than or equal to 94, then the yellow LED be on. And then if the readout is greater than 94, the red should be on, the other should be off. Alright, let's hit F5 and see if we did it. So now, once we get up over 79, the green LED should go off and the yellow one should go on. We're almost there. Oh, there we go. We're over 79. See if we can drop it down, see if we can actually get a 79 value here. Okay. Green, yep. Right on the cusp. Alright, so over 79, the yellow one's on, the green and the red one are off. Now once we get over 94, the yellow should go off and the red should come on. Almost there. There we go. Just over 94. The red's on, the others are off. And we drop back down below 94. The yellow one's on. And we drop down below 79. The green comes back on all the way to 0. And there you have it. That's the beginner-based solution for lesson number 6. I hope y'all enjoyed it, and looking forward to doing more fun with these as they get more complex, and learning right along with y'all. I hope y'all have a good day, night, afternoon, morning, whatever time it is that you're watching this. And thank you for watching, and sorry this went so long, but we did a little troubleshooting. We forgot something in our code, and we did it all in real time. So y'all have a good one, and we'll see y'all next time. Bye for now.